Welcome back everyone to the Hello World Guide. This is another episode of the OpenGL 3D Renderer series, and this is actually going to be the last episode. And in this, we are finally going to figure out a method to, just go ahead and try to figure out how to actually load the meshes. So currently, we are loading and processing the nodes and files, and we are not actually dealing with how the meshes actually. So we are not getting anything on our screen. So that is what we are going to do in this video. So yeah, let's get started with that. The first thing we'll have to do is to actually we'll need a we'll need like an scene pointer as well in this process node function. The reason for that, we'll get to that in a second. You'll understand the reason in a second, but we also need to get the AI scene pointer. Actually it needs to be constant, so const AI scene pointer called scene, just like that. And we will also need to make sure that we put this in the CPP file as well. And the reason we need to get this is because we actually need to use this scene pointer inside of our when in order to access the meshes, because the meshes are stored in the scene. What does the node contain then? Well, the node only contains a list of indices to the meshes. So now, yeah, that's basically what we want to do. We want to we want to make sure that we actually pass the scene here as well when we are calling recursively. So what we want to do is we want to access the indices from the node and then use the scene to actually get the actual meshes, and then use that to transform the meshes into our mesh class and then render that. So yeah, let's get started with that. First of all, you want to ensure that the process node, in the process node you also pass in the scene here in the original process node. Now inside of process node, what we will do is we'll go through each of the node meshes. So actually we need to say less than number of meshes and num meshes. So for each mesh, it will basically contain an index, or this is basically an array of indices to the actual mesh in the scene. So we'll create a function called process mesh for processing the actual meshes, and we'll call this just process mesh. And let's create like an AI mesh pointer called mesh. It will only take one argument, and it's actually not going to be void, but instead it will return a mesh. So that is awesome, I guess. And you can remember that we had a transformation property in mesh. So what we are going to do is we are going to create a mesh called mesh and set it equal to the process mesh function. And of course we are going to get the scenes meshes and use the node mesh indices to actually get the correct index to check in the scene meshes. So we'll say node m meshes, and then we'll pass the I index here, which will get us the correct mesh, and we'll process that mesh to get a mesh in our terms, not an AI mesh but our mesh. And then we'll say mesh dot transformation is equal to the transformation variable that we have got, and in the end we'll say meshes dot pushback our mesh, so that we actually have the mesh inside of our model here. And now what we can do is we can go ahead and create a implementation of the process mesh function here. And you can see it's giving an error because mesh does not have a default constructor. It requires us that we provide it a vertex array, actually not vertex here, glm vec3 for vertices, and an array of vertices, and also an array of indices for the mesh. So we'll go ahead and create an array of vertices here, like that, and a vector of vertices actually for more proper terms. And we'll also create a vector of unsigned in 32-bit integers called indices. And after we have done that, we'll just pass that to the constructor when we are returning a mesh here. So we'll just say return mesh with vertices and indices. And now all that is left to do is to populate this vertex and index data correctly. Now the AI mesh actually has a bunch of properties here, so we'll go for, and you can see if I go m num, you can see there are a bunch of things here, like we have got bones and animations, and we have got UV components, but the only two we care about are vertices and face. So we'll first of all start with m num vertices. So we'll for each vertex we'll basically push that back in our vertices vector that we have got. So we can say vertices dot push back, and we can create a new glm vec3 here. And what we'll need to do is actually that won't work, so we'll have to go and say mesh m vertices, and you can not just pass that directly, because this vertex file is a it's like a it's like an AI vector 3D. It is a vector 3, but it won't work because it's of course not a glm vec3, and there's no way to convert between the two automatically, so we'll have to do that manually. So we'll create an AI vector 3D called just vec, for example, and set it equal to this, and we'll create a glm vec3 by passing vec.x, y and z separately to this, x, y and z. So yeah, after we have done that, what we can do is we can go down here and say mesh, and go ahead and choose well, there are a bunch of other stuff like normals here, but we need to worry about the faces, and we currently there are like multiple vertex attributes like the position and the normal, but we don't use normal yet since we do not have lighting yet, so we will leave that out, and we will go ahead and implement the next for loop, which will be for the number of faces, so faces like that. So for each face, what we'll do is we will create an AI face pointer called face, which will set to mesh m faces, and we'll get that particular face that we need. So we can say, actually this does not need to be a pointer, it's just a face, and we'll pass in that index. So the face basically has like a list of indices, so we'll go for like we'll get how many indices it has, num indices actually, not just indices. So for the number of indices it has got, we'll basically put that index back in our indices array. So we'll say indices dot push back, and we'll say face dot face dot m indices, and we'll pass I as the index to that array, and this basically is an array of unsigned integers, so it should work correctly. And let's just remove this here because it's just a single statement, we don't need the braces, and that is all we need to do to process our meshes. And with that, we have got that system kind of implemented for loading our model and setting the mesh correctly. Now we should be able to have the mesh data all right here. So what we can do here is we can go and remove our manual mesh that we created, and in the constructor we can just pass in a file name like scene.fbx. For example, your file can be saved in many different formats, and it can be have any name, of course. So here I've got like a very simple scene in Blender, like that contains only the default monkey that we have got, and like this what do you call it, scare, like this, just like a floor or something, and it also contains this, which is just a sphere. And of course the Blender has got like lighting effects, and very basic kind of lighting effect. It's got some shading that helps us differentiate between the different surfaces, but our engine currently renders everything as flat, so we won't really be able to see it in this way, but we'll be able to currently see it, like we'll be able to make out the shapes, kind of the outline of them. So let's go ahead and run this and see what happens. So I'm going to compile and run the actual program in here, and we actually we want to ensure that we export this as well, because this is Blender right now. I'll export this as an fbx, scene.fbx here, we'll just export in the main program directory. And by the way, there are a couple of things worth noting. Firstly, I have removed all transformations from objects. Secondly, I have made the camera be at position 10, so it's a bit far away. And when you're exporting from Blender, you might want to make sure that when you export as an FBX, you set the scale to 0.01, because it will make it in centimeters, and we don't want it in centimeters, because we have kind of made our speed and camera positioning everything to be as if in meters. So making it in centimeters might cause problems. Of course, you can change it here as well to use centimeters, but you can see that we have got our monkey and our sphere and our floor here as well, and everything is rendered correctly, and the vertices are completely read from the file that we had, and that is pretty awesome. So yeah guys, this is pretty much it for this video and this series, and I originally intended to create a lighting section in this series as well, but maybe we'll do that sometime later if you guys want me to. If you want to see the lighting section, then let me know in the comments. And for now, this is pretty much it for this series, and in the next video we'll start the next series. And if you have got some cool ideas about them, about the next series, then let me know in the comments so that I can incorporate them. And yeah, I'll see you in the next video and the next series, so make sure to like and subscribe so you don't miss that, and share this video with other people as well, and bye.